This video will cover the dopamine direct and indirect pathways. The system that I'll be discussing here is the nigrostriatal dopamine system, which is involved in planning self-initiated movements and adjusting posture, and it is this system that, when it degenerates, leads to Parkinson's disease. This system begins with the substantia nigra, which projects to the caudate nucleus and putamen, as well as the globus pallidus. Projections then include the subthalamic nucleus and VA-VL nuclei of the thalamus, before projecting back to cortical regions. You see here the same system in schematic form, pointing out the direct pathway versus the indirect pathway. The direct pathway is an excitatory positive feedback loop. There are two consecutive inhibitory influences, so stimulating the first inhibitory path inhibits the second, which disinhibits the final excitatory path. So you see here that the cortex is excitatory on the putamen. The putamen inhibits the globus pallidus, but the globus pallidus was inhibitory on the thalamus. So we remove that inhibition, allowing the thalamus to excite the cortex. In contrast, the end result of the indirect pathway is inhibitory, and so it provides negative feedback. Here, the inhibition by the putamen on the globus pallidus external removes inhibition from the subthalamic nucleus, which excites globus pallidus internal, which then inhibits the thalamus, reducing excitation. So what might the function of these pathways be? We've learned that the direct pathway excites the cortex, and the indirect pathway inhibits it. So these are two opposing functions, which might serve to sort of sharpen motor control or give more discrete control over motor functions. So what is the role specifically of dopamine? Well, there are two dopamine receptors, and D1 receptors lead to excitation of the direct pathway, D2 to inhibition of the indirect pathway, so both lead to increased excitation of the cortex. So this is just showing you the input from the substantia nigra into these direct and indirect pathways, showing the D1 excitatory receptors and the D2 inhibitory.